have the same guy in English. I thought all the time it's Louise, but I couldn't. No, they just act so differently on his lessons, and I was like, why is there such a different people on each, like different periods? I thought maybe they're different. I just look the same, but I didn't know that he has a twin brother.
Yeah, he does.
Wow, 21 days of school left, and just now realized it.
22.
No, it's supposed to be 21. The person that's supposed to change it hasn't done it yet. Okay, hello.
Hi.
All right, volume of slicing. Okay, so this is another way of actually doing this, but instead of actually having rotations, we're actually doing other shapes that are going to be three-dimensional and are going to have a volume. So, volume of a slice. So, area of a cross-section, so I need to know the shape of the cross-section and to be able to find the area of that. So if it's a square, then I use the area of a square. If I use a triangle, area of that. And thickness of the slice, which would be my delta x.
This is basically an integral, but just
for each x in that, the area A of x, the cross section of the solid is known as continuous, and the volume of V is solid, is right there.
It looks like just an integral.
It is.
That's all it is?
Yeah.
This is all 6 polynomials.
So, now, so this is the area of the shape, right?
So it's like
And this is how tall that shape is, right?
Yeah.
And this is the delta x, which is the thickness of the area.
Yeah. So it's like basically the integral of the integral?
No.
I mean like...
Integral of the area.
Yeah, but area is the integral of a function. Isn't it?
Yes, but
So it's going to be...
it has to do with shapes that are different, that are not regular functions.
Alright.
Okay. All right, so slicing to verify volume right here. All right, so I'm going to start with this.
This is cylinder, is it?
Cone.
It's a cone.
Oh,
That's it.
Okay. All right, so what we're going to do is we're going to go through and I'm going to do some relations on this. So if it's a cone, it's going to look something like this. And then I'm going to have right here. So from here to here is going to be the big R. From here, this is my H. But from here to here, this is the little r. And from this value is going to be my x. So h would be the height of the cone, right?
Yeah.
Where x is the height at some point, which is relation to the r, the radius of that point. They're similar. They're going to be similar, so they're going to be proportional to each other. So wherever this r is, right here, I'm going to have another r somewhere over here, where it is going to be proportional to the height h is to x. So I know that r to x is going to be proportional to big R to whatever my h is. Did I completely lose you?
No.
Do you know what I'm talking about?
Proportions,
Yeah, I'm setting up a proportion because I have too many variables here anyway. So I'm going to set up my proportion here. So I'm going to have, because I'm going to do this as a dx, and so I want to try and figure out what my r would be at any point, wherever this is through here. So it's going to be r h is equal to big R x. So r is equal to r x over h. Yes? I did a proportional, I just got the r by itself, right?
Well, we're trying just to prove that the...
I'm proving that this is the formula.
Oh.
I'm proving that formula.
This is geometry.
Oh, okay. In your country, yes.
Okay. In my country, this is like.
Okay, so we're gonna do the same thing that we did a minute ago. So what I just said, that I have my integral from where to where, from 0 to whatever my h is, right? 0 to h. Yes? Because that's going to be the height to that. And it's going to be the area. Okay? What's the area of my pi r squared, right? So it's going to be pi r squared. And that's a circle, right? There's pi r squared. And from my formula, I'm going to have a dx because it's going to be the thickness of those, right? Dx is the thickness of each one of those little circles that I have.
Yeah.
So, now, what is r going to be equal to? Rx over h, right? So, I'm going to have integral from 0 to h of pi. It's going to be r squared, so I square these, so it's going to be r squared x squared over h squared dx.
Oh, I see how it works.
Because I'm taking the area of the circle, which was here,
Ah, okay,
that's a slice,
it's already formula here.
okay? And now,
So it's gonna be just
what's the only variable I have here?
x.
I have x, because it's going to be dx, right?
Yeah.
So I'm going to pull out everything else in front. So I'm going to say that I'm going to have pi r squared over h squared integral from 0 to h, right, of x squared dx.
Okay.
And now we take an integration, right? So we're taking an integration of that, so it's going to be x cubed over 3, right? So we have pi r squared h squared times my integral, which is going to be from x cubed over 3 from 0 to h.
And if you plug it in, the h squared and h cubed is gonna cancel.
Yep.
And we're gonna have to find.
So the bottom part's going to go away, right?
Yeah.
And so what's going to be left is going to be, plug that back in, it's going to be h cubed, right? And h squared on bottom is going to cancel. So I'm going to get pi r squared h over 3, which is
Is this how you're supposed to find the formula of cylinder, or is just the calculus way?
calculus way. And we're just using this to verify it. We're just verifying it.
But there's another way, like how to do it in geometry, right?
Yeah. So you guys aren't going to have to do much verifying, but I'm going to show you guys the problems more. So yeah, here it is right here. Same thing, similar. A solid has a circle base, radius of 3. Find the volume of the solid if every plane cross-section that is perpendicular to a fixed diameter is an equilateral triangle.
Right, solid is circle. What is the equilateral triangle? Oh, is it the one with like two sides?
All sides.
Oh, all sides, okay. I just don't know the language. Hard language here.
A solid has a circular base of 3.
Wait, how is the...
It's a cylinder, yeah.
Hmm?
It's a cylinder, no? Or no?
No, it's not cylinder. It's more of a jello mold.
Oh my god, yeah, that's what it is, like, it looks so weird.
Cute.
Jello. It's a jello mold. Okay. Base of radius 3 units. Okay. So we're bigger. So the biggest
Okay, so
equilateral
let's
triangle side is gonna be 3, right? Like the radius is 3.
Radius is going to be 3,
So
right?
So the biggest side of the triangle, the one that's in the middle slice, is gonna be 3 too. I know.
Radius is 3, right? But if we go back to this,
The one in the middle.
okay, but if this was on the axes right here, I get 3 this way, 3 this way, 3 this way, 3 this way.
Yeah.
But if it's equilateral, this is 3, right?
Yeah.
This is 3, right?
Right.
This is 6, right? That's 6.
Yeah.
Yeah.
That's important. Okay? So, I'm going to go back to this. And, so, like I said, it says circular base. So, in that triangle, with the circular base, I have a value. Okay, because I need to have a formula for this too, right? So the other one uses y's. That's fine. So we could say y here, 2y, 2y, and the height of this would be, no. It's always going to be proportional, because if this is an equilateral triangle, what do we know about the corners of the equilateral triangle?
Wait, what? The corners of
The corners. What do we know about the?
It's gonna
Huh?
be.
like
Not 45.
No, square
The
root
angle?
of 3y.
Yeah, angle 60, and so that's going to be what? The height would be what?
I'm slow. Never mind.
Oh wait, 6 angle. Oh.
You're right. I just wanted you to say.
Square root of 3.
Yeah,
Y.
because this is a special right triangle. So this was a 60, 60, 60, right? But then if I break it in half, it's a 30, 60, 90, right? And so this height would be the same as saying
Square root of 3y.
y square root of 3. I just want to have my variable up front, okay?
Or you can just find the Pythagorean theorem. Or you can just find it from Pythagorean theorem.
Yeah, Pythagorean theorem, yeah. Okay, it's fine.
Anyway. I didn't take geometry here, so I don't know any
No,
definitions
it's fine.
from geometry.
Okay, so we now know that it's going to be from where to where. Where is this going to start at? So if it has a circular base,
Yeah.
so on my axes, this would go from where to where?
From -3 to 3.
-3 to 3, right? So it'd go from -3 to 3, right? All right. So now, we now how do I find the area of a triangle?
Half height times the
Okay, so a triangle would be 1/2, right?
height.
Base. What's going to be the base of this?
2y.
2y times my height, which is
I mean, or y. Square root of
y square root of 3,
and it's dy.
and I'm going to have dy. Because from my formula, that's basically what I have. The area of my cross section, area of whatever my cross section is from here to here, and dx is going to be the thickness of that. All right, so let's go ahead and put those together. So I'm going to have rad 3 over 2, right? And it's going to be,
2y.
no, wait,
No, it's gonna be just
rad
2y.
3, right?
2y and
Yeah, because that 2 will cancel that. So I have rad 3, and I have,
2y.
not 2y,
That was good.
y squared. Y squared dy from -3 to 3. All right, let's go ahead and do the math.
And rad 3 over 3
Okay, so it's going to be rad 3 over 3y cubed from negative 3 to 3. I'm hoping you guys can notice the issue we're going to have here in a second, but you'll notice it here.
No, it's not going to be negative.
Okay, so let's see. Let's go ahead and put these in. It's going to be, what's that, 27 divided by 3 is? 9 rad 3.
Oh, it's going to be 0.
Minus,
Negative. Oh, no, it's not going to be 9. It's going to be plus 9 rad 3.
yeah, because I have negative right here, right? Negative, that's a negative, so it's,
Plus, minus 9. It's going to be just 18.
so I get 18 rad 3.
So what was the issue?
So you guys got to keep, whenever you have like this, in this symmetrical, okay, because if you come up with 0 right here, what has to happen?
One part is negative, one.
Yeah, so you will have to double check on that. So whenever you see from here to here, same thing, yeah, that's one thing that you have to be careful for. So whenever you see that. But on this case right here, since we did have a negative, if this is square, I would have had an issue. But since it's cubed, it's not.
So are we gonna have something that I would
Yep. All right, I'll leave off here. You guys could